Okay, today we're going to continue and try and solve triangles. We've got triangle ABC where angle B is 124 degrees, A and C are 15 and 20. So let's just go ahead and draw an obtuse triangle. We'll make this, has to be the 124 degrees, so that's angle B. We can make this A and this C, doesn't matter, and complete the triangle. So opposite angle A is side A, or 15. Opposite angle C is side C, or 20. And of course, opposite side B is side B, or angle B is side B. Okay, so what we have to this point is the law of sines, which says that A is to the sine of A, as B is to the sine of B, as C is to the sine of C. So if we fill this in, side A is 15. We don't know angle A, so we just write it as sine A. Side B we don't know, is to the sine of 124. And side C is 20 over the sine of the unknown angle C. Now, no matter which two of these you pair together to make an equation, you're going to have sine of C, B, that's two unknowns, we can't solve that. Sine of A, B, that's two unknowns, we can't solve that. And if you take the first and the last, you're going to have sine of C and sine of A, that's two unknowns. So we can't solve this triangle using side angle side. That means we've got to come up with something else. So if you remember when we started the law of sines, I said that we cannot be used for, so law of sines cannot be used when we are given side angle side, which is what we have here, two sides and the included angle, or when we are given all three sides and no angles, side, side, side. So what we need to use now is going to be the law of cosines. The law of cosines says for any triangle, doesn't matter, so side B, side C, side A. Law of cosine says we're going to relate the angles and the sides here. It's actually very easy to memorize. Pick any side. A squared is equal to C squared plus B squared. Now that looks like the Pythagorean theorem. However, that's not a right triangle. It's any triangle. So we're going to continue on. These two sides minus 2 times C times B. And then it's always going to be multiplied by the cosine of that angle. So angle A. And that's the law of cosines. I can write it two different ways, or three different ways total, two different ways than this. I can pick side B. The other two sides are going to be A squared plus C squared. So I minus 2 times A times C and multiply that by the cosine of the angle opposite this side. And of course, C squared is equal to, the other two sides are going to be A squared plus B squared. So minus 2 times A times B. And then I'm going to go to the cosine of the angle opposite side C, or angle C. It's the same equation, just written in particular for each side. So if I look at this triangle, I know the angle 124. The side I'm going to go with is B. So I'm going to go with B squared is equal to A squared plus C squared minus 2 times A times C times the cosine of angle B. So B squared equals A squared is 15 plus C squared is 20 minus 2 times 15 times 20 times the cosine of my angle B, which is 124. And you can see it's a nice simple equation. I only have one unknown, which is B squared. So we got 15 squared, that's 225, 400, so that's 625. Minus 2 times 15 times 20, I believe that's 600. And now you got to take the cosine of 124, so on your calculator, take the cosine of 124. Remember, you must be in degree mode. And I got 0.5592, rounded to 4 decimal places. Now, don't round, just leave it in your calculator, multiply it by 600, and then negative 600, so that's going to be addition, then add that to 625. So I came up with that b squared equaled 960.5157. Again, that's rounded just to 4 decimal places to right here. Taking the square root of both sides, I came up with b is approximately 31. And does that make sense? Well, remember, in a triangle, opposite the largest angle will be the longest side. So if b is equal to 31, that makes sense. All right, now how in the heck am I going to find angle A or angle C? Well, when you solve a problem, you're only going to use the law of cosines one time and one time only. After you've solved that, we now have enough to use the law of sines to find either measure angle A or angle B. I'll find A. So side A is to the sine of A, as now we have side B is to the sine of B, which is going to be 124. And now that equation has one unknown, so I can solve that. And if I can slide this board up just a bit, I can finish that out. All right, so solving for sine of A, I'd have to multiply both sides by sine of A, putting in the numerator up here. So that would be 31 times the sine of A. So I'm going to have sine of A here is equal to 31. Sine of A is up here now, so I'm multiplying both sides by sine of A. Right, they cancel out here, leaving 15. And I'm going to have to divide both sides by 31 and multiply both sides by the sine of 124. So take the sine of 124, multiply it by 15, and divide by 31. You should come up with the sine of A is equal to 0.4011. Again, that's just rounded. Leave it in your calculator. And then we're going to take the inverse sine of both sides. Again, making sure you're in degree mode. And you should come up with A is equal to about 23.6 rounded to the nearest tenth. And of course, finding the measure angle B, real simple. You've got a triangle. All three angles add up to 180 degrees. So B is equal to 180 minus 124 plus 23.6. So B should equal about 32.4. So back to what we did different today was just for any triangle that is side angle side, and I'll do tomorrow the side side side. We cannot use the law of cosines. We must use law of sines. You simply pick the side opposite the angle you know and create your law of cosines, and it's pretty easy to memorize how it works. And then just solve through it and use your law of cosines or law of sines after that. Okay, ask me any questions you have on Google Classroom. I'll be happy to answer anything I possibly can.